Hello, today's lesson is on 15.4, compound events. Okay, this is a fairly involved section, compound events. So hopefully by the end of the hour here, or the end of 20 minutes, you'll have a good idea. I got a short little tidbit for you at the end, but let's go through the lesson and let's get started. Okay, so today's essential question is the following. How can you find the number of possible outcomes of one or more events? So the title of the section is compound events. And so by the end of this lesson today, you should have a good grasp on using tree diagrams, tables, or formulas to find the number of possible outcomes. Okay, that's the first thing, number of possible outcomes. And then we're going to, by the end of the lesson, you should know how to find probabilities of compound events. So in this section, the examples that I have ahead of you here, I'm using tidbits from the book. So it should go pretty quick. And if you have questions as you go, just make sure that you write them down and reach out to me. I'll help explain them further. And let's go to the first example. Okay, so what this is, the question is this. You randomly choose a crust and style of pizza, okay? Find the sample space. How many different pizzas are possible? So this is the question here. Got the crust and you got the style, all right? And the answer is here, okay? So the answer key is here. All right, so I just want to distinguish that in the question. So crust, we have two different types of crust to pick from: thin crust, stuffed crust. Okay, we have 4 different styles of pizza. We have Hawaiian, we have Mexican, we have pepperoni, and we have veggie. Okay, so what we're trying to do is we're trying to determine the number of different pizzas that we can make with the 2 different types of crusts and the 1, 2, 3, 4 different styles of pizza. All right, so this is called a tree diagram. And basically, you start out with the crust, thin, okay? And you make your little tree here. Okay, it's kind of a sideways tree. But you have thin crust, you have a Hawaiian pizza with thin crust, a Mexican pizza with thin crust, a pepperoni pizza with thin crust, and a veggie pizza with thin crust. This is probably what my wife would order. So if you look at the bottom here, you have stuffed crust. Stuffed crust would be Hawaiian with stuffed crust, Mexican pizza with stuffed crust, pepperoni pizza with stuffed crust, and veggie pizza with stuffed crust. Okay, so what you have is outcome. This column, you can see that you've got 8 different outcomes. Okay, and I'm not going to read them all. Thin crust Hawaiian, thin crust Mexican, thin crust pepperoni, thin crust veggie, stuffed crust Hawaiian, stuffed crust Mexican, stuffed crust veggie pepperoni, and stuffed crust veggie. So what you have here is you've got 8 different outcomes. So there's 8 different outcomes with 2 crusts and 4 styles of pizza. Okay, so that's our first example today, using the tree diagram to determine the sample space. So this is one on your own. They're going to stuck this one in before, the key idea here. Let's say the pizza shop, I'm just going to put my screen on. Let's say the pizza shop adds a deep dish crust. Find the sample space. How many pizzas are possible? All right, so they have the 2 types of crust, thin and stuffed. Now they're adding a deep, okay? So that's the same question. Now they're just adding another crust, a deep dish. Okay, so for the sake of the the case here, I've got it prepared here. We're using a tree diagram again. So you have your thin crust and your stuffed crust. Okay. Now you would have 4 more options for the deep dish. Okay, so the deep dish would have four more outcomes. Okay, so you'd still have deep dish Hawaiian, deep dish Mexican, deep dish pepperoni, and stuffed crust veggie. Okay, so you can see you'd have your 4 from the thin crust, 4 from the stuffed crust, and you'd have another 4 from the deep dish for a total of 12. So your answer there would be 12 different samples of pizza for that one. Okay, so this brings us to our key idea today. It's called the fundamental counting principle. So there's another way to find the total number of possible outcomes is to use the fundamental counting principle. And what that is that if you have an event M that has M possible outcomes and an event N that has N possible outcomes, the total number of outcomes of event M followed by event N is M times N. Okay, so if you look back at this example back here, we had 2 crusts and 4 pizza styles, and that gave us 2 times 4, or 8 in the original, 8 possible pizza samples. Okay, 8 possible pizza samples. So, and when we did the second question, we added another crust. So we had 3 crusts, 3 times 4 pizza styles, and that gave us an answer of 12. 3 times 4 is 12. Okay, so we can use this fundamental counting principle to help us come up with the number of outcomes when you have event M followed by event N. Okay, so let's look at example 2, which is finding the total number of possible outcomes with this question right here. Find the total number of possible outcomes of rolling a number cube. So how many possible outcomes there? You'd have 6. And flipping a coin. What's the total possible outcomes there? You'd have 2 possible. You have a heads and a tail. Okay, so the book spells it out kind of nicely here. Basically, it shows you both ways. They have a nice little chart. And then the second way is by using the fundamental counting principle. All right, so let's look at both. Method 1. So method 1 has the number cube with the number 1, number 2, 3, 4, 5, and 6. And then we have the quarter over here with the heads and the tails. Okay, so you have the number 1 is rolled with the heads, 2 with the heads, 3 with the heads, 4 with the heads, 5 with the heads, 6 with the heads, and same with the tails, 1 through 6. So as you can see, you have your 6 outcomes for the number cube, 2 for the flipping coin, and you can see you've got a total of 12 possible outcomes using a table. Okay, now the other way is just by using the fundamental counting principle. Okay, so the fundamental counting principle, same question, but now if you look at the 2 events, you have event 1 has 6 possible outcomes. You have event 2 has 2 possible outcomes, heads or tails. So using the fundamental counting principle, you have 12 possible outcomes. Okay, so we use the table for number 2, and we use both the fundamental counting principle. Okay, example 3, finding the total number of possible outcomes with an example here of how many different outfits can you make from the t-shirts? Okay, so before I review the answer here, here's our closet. We have 2 pairs of jeans. Okay. And we've got 1, 2, 3, 4, 5, 6, appears to be 7 different colors of shirts. And we have 3 different pairs of shoes. Okay. We're not really getting picky on what goes with what. Okay. So just kind of put that off the side. We're just looking for combinations. All right. So we're going to use the fundamental counting principle with that. All right. So using the fundamental counting principle, let's take a look at each event. We already kind of answered some of these. T-shirts, 7. Jeans, 4. Oops. I thought this was only 1 pair of jeans, but there's actually 4 pairs. Let me just erase that. So there's a pair on top of each other. So there's 4 pair. And event 3, you have 3 possible shoe choices there. Okay. Now, so what are the examples here? So what are the samples? So we're going to take the 7 shirts. We're going to multiply it times the 4 pairs of jeans. And then we're going to multiply it by 3 pairs of shoes. And we're going to get 84 possible combinations using the fundamental counting principle. 84 outfits. Okay. So as you can see there, this would never fly for me because I'm colorblind. My mom would have sent me back upstairs and said, okay, go back up and put something else on. Okay. But if you were not colorblind, if you could just put whatever you want on, you've got your jeans, you've got your shirts, and you got your shoes. You have 84 different outfits that you can wear from that closet. Let's take a look at this one. All right, on your own, number 2, find the total number of possible outcomes of spinning the spinner and choosing a number from 1 to 5. Okay, so you've got 5 choices of choosing a number. Okay, 5 choices. 1, 2, 3, 4, 5. All right. So then we also have on the spinner, we have 4 different spots, 4 outcomes. So you have 5 numbers, 1 to 5, but you have 4 different colors on the outcome on the spinner. So it tells you that you're going to have 20 outcomes for number 2, which would be the total number of possible outcomes of spinning a spinner that had 4 choices and landing on a number from 1 to 5. Okay, on your own, number 3. How many different outfits can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes? Okay, so again, this is fairly simple. 4 shirts, we're using the counting principle, 5 jeans, and 5 shoes. Okay, so 4 times 5 is 20. 20 times 5 is 100 different outfits. Okay, 100 different outfits. That would not fly in my closet for number 3 there. All right, now we're going to get to the compound event. We have 2 more examples today, and then I'm going to cut you loose on your assignment. A compound event consists of 2 or more events. As with a single event, the probability of a compound event is the ratio, okay, the ratio of the number of favorable outcomes to the number of possible outcomes. So we have to use the counting principle to help us with this possible outcomes. And we're going to also use it, but we have to do a little identifying on the favorable outcome side of things. Okay, so let's look at example 4 here. Finding the probability of a compound event. So let's take a look at the question first. In example 2, what is the probability of rolling a number greater than 4? So you're going to roll a number that's greater than 4. And if you look back at example 2, we had 12 possible outcomes. Okay, so we had 12 possible outcomes from example 2. So there are 2 favorable outcomes in the sample space for rolling a number greater than 4 and flipping tails 5 and t. Okay, so the probability of this event is going to be 2 over 12. Okay, so you've got to think about this. What is the probability of rolling a number greater than 4 and flipping tails? Okay, so the number of times that took place was only 2. Okay, the total number of possible outcomes was 12. Okay, I had that little note here. So if you wanted to go back to, again, we're looking for the probability of rolling a number greater than 4, so 5 or 6, and flipping tails. Okay, so flipping tails 5 and 6, that would be this outcome and this outcome. Greater than 4, and flipping tails would be these 2 outcomes. Okay, so only 2 times there in that chart, we noticed that we had ourselves a favorable outcome. Okay, so in that case, 2 out of 12 probability in example 2 of rolling a number greater than 4 and flipping tails. So 1/6. The probability is 16 2/3%. 16 2/3. Okay, last example today, folks. We are going to look at flipping 3 nickels. What is the probability of flipping 2 heads and 1 tail? Okay, so the first thing here is on this little tree diagram, we're going to flip 3 nickels. So we have heads and tails, 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 heads and tails. So we're flipping, you flip to heads, okay, then you flipped another heads, then you flipped another head. So there's your 3 nickels that you're flipping. So here's your outcomes. Okay, so your outcome column will show the 3 heads. Okay, now your second combination using your tree diagram, you have head, you have a heads, you have a heads, and you have a tails. So HHT. So as you can see down here, you've got 1, 2, 3, 4, 5, 6, 7, 8 possibilities. Okay, 8. So when we're finding the probability of flipping 2 heads and 1 tail, we're looking at just these ovals. Okay, the 2 heads and 1 tails, 2 heads and 1 tail, 2 heads and 1 tail. So in that case, we have 3 ovals over a total of 8. Total of 8 possibilities. So 3/8 or 37.5%. So that's your lesson today on compound events. So take a good solid look at that. I don't want to go any further than that today. I've got a short little assignment for you, and I'll probably just have a follow-up email to you sometime. But take a look at your teams. You're doing a great job with that. And if there's any questions on this assignment, make sure you reach out to me. I'm looking forward to seeing you guys soon. Take care now.